Hello, everyone. Thank you for coming today. My name is Florin, and I'm going to speak about how to get your Go application from a development environment to a production environment. A few words about me. I'm a developer at heart. I've been developing for a decade almost. I'm an ops by mistake because people get me to do things with servers and deployment pipelines and so on, so I'm like DevOpsy. I'm one of the Go plugin for IntelliJ maintainers, and in my spare time, I'm also contributing to various open source projects and trying to help Gophers on Slack and every other channels that I can think of. So today we'll cover a few areas that I think many of the Go apps or in general applications are not really thinking ahead of time, and they're covering late in the development process. We will be speaking about logging, building your application in Go and the specifics for it, testing your application, because normally if you ship something to production, you should test, no? I think. Doing some benchmarking and profiling for it and see how you can optimize it. Doing the deployment part, and finally doing some monitoring for it. So let's start with logging. How many of you actually start thinking about logging at the time when you're thinking about your application? Or how many of you think about, okay, I'm going to need this information in order to know what's going wrong in my system? Okay, that's a good number. I was expecting lower. So that's a good start, half of the room. So the things that I think are essential for logging in any application would be, first of all, you can maintain a single unique log message across your entire application, especially if you go microservices. So one of the things that you would like to log always would be a file name and a line number for where that message came from. That's very useful later on in the debugging part where you're like, okay, I have this message, now what? Where did it came from? So that's pretty important. Normally you would also like, if you run any decent scale at any decent scale, you'd also like to have a machine-readable format for your logs, so a structured log. And as we've seen earlier, DigitalOcean, for example, uses that to have many information displayed in them. You will also want to have a context of errors in case you're logging what happened in your error. So besides the error message, you would also like to have things like, let's say, the request ID or any other variables that play a part in actually computing your context for which the error happened. That's pretty important, especially when you start realizing, I've sent that the username is invalid. Well, which username was invalid? Was it invalid because it had some special characters that you're not supporting, or because of a length that it didn't met? So those things are pretty important to log. Another question which often comes on is, where should I log? Should I log to a file? How do I deal with log rotation if I'm logging to files and so on? My take on this would be a log to either your standard out and standard error, or syslog, depending on your needs, and let something else handle the log processing for you, log shipping, aggregating that to a different environment that processes and deals with logs. And finally, don't spam your logs in production. Means basically use the error levels that your application has defined. So use info for logs that you want to run in development environments, and there you can actually log as much as you want. So log everything in info if you want. But in production, maybe you want to only log errors or really meaningful information that won't spam you. Think about an application which runs, I don't know, millions or billions of queries a day. You might not want to produce billions and, I don't know, times 5 log lines just so you have logs. There are different methods to handle other information, and we'll cover them later on. I've talked a bit about structured logging, and I said it's good to have it. I want to give a quick example of what that means. Normally, you would see unstructured logs, which would be maybe something like info, and then, yeah, a row string, which is nice to read for us humans, because you are like, yeah, okay, I can read this. But yeah, the machine won't do so well in parsing that. It's better to have something like, okay, I want to know the type, I want to know the file, the location where the log message came from. I want to know the request, as I was saying earlier, and maybe the username or anything else that you consider relevant. In Go, there are many different libraries which allow you to structure your logs, but also you can have some libraries which are not dedicated for structure logging. A few popular ones are the ones I've listed, and there are many, many more out there. I'm not going to recommend you like use Logras or GoKit log or anything. There are different purposes for each of them. I know Uber has released Zap I think a month ago, so I'm not sure if that's the one that you want, but look into what each of them does and see which one fits your needs. So we have a log layer in our application. We know what happens when we run the code. I would say it's time to go and build the application. To build the application, you would need a few things. You would need your dependencies in place. So any code that you import from third parties, you would need to have at the time of building. You would need to do some testing so that you know that the build is fine and that the code you're producing is working. And finally, you want to actually build the application. In Go, we call vendoring as a way to manage our dependencies. And by vendoring, we usually mean take the import path that you have. So for example, if you have github.com dlsniper demo as an import in your application, you would like to have that vendored, or better said, copied into your project root directory vendor, and then the same import path. And what that allows you to do is to isolate a certain package at a certain version, and that will be consistent across machines, which we'll come back later and see why it's useful. This feature was introduced in Go 1.5 as experimental. It is here to stay since Go 1.7. In 1.6 was turned on by default, but you could turn it off. But now in 1.7 you can't turn it off. There's a big problem right now with vendoring if you are producing a library. So right now it's not recommended to do that because the Go compiler will actually not be able to compile the application of the end user. So if you are working on a library and shipping that to other users, if you have any vendor folder in your library, they won't be able to build it. There are a few tools that are worth mentioning. There are many, many others out there, and they are all satisfying different requirements. Again, I've listed a few that I've seen that are more popular among users, but that doesn't mean they're all equally popular, or the other ones that are not here are unpopular. It's just a quick list to give you some examples. GB stands a bit out from these tools because it also allows you to have a different level of building the application and have a different structure for your application. So it goes a bit further than the other tools. When it comes to dependency management in Go, I would say treat your dependencies as you treat your code. So let's say you want to import a package which does some computing for you, maybe some crypto library. You would want to make sure that that library is actually secure, and you would want to make a code review on that, see what happens. Or if you import a logging library from what I've said earlier, check what it does. You will never know if it's a good library or not until you go at least through the code and see, hey, okay, is it doing something that I would do or not? Is it something that I can learn from? Or maybe I should submit a PR to fix some problems. That will help you in understanding, okay, this is my dependency. I know it does this thing, and it won't break my build because, I don't know, something strange happens. You always want to build your binary the same way you build in your development environment. You will want that in a CI environment as well. And finally, you would want that in production. So, for example, if I'm building an application right now on my machine, I would like to make sure that my CI system also builds the exact binary that I have. It doesn't have anything new in it, or it doesn't have anything surprising in it. And that's where vendoring comes in. By freezing your dependencies in a certain place in time, or a certain commit, you will be able to always build from the exact version of your dependencies, which is pretty important. Especially right now, since we don't have a good way to specify I want this version or that version of a package, things might break. And since GoGet, for example, depends on latest master version, you might commit now something on your machine, it might work, your CI system might break, and you don't want that. Or even worse, your CI system might actually work, but build a binary which does something else. And that's not good in production because you might risk losing data, for example. I would say commit your vendor folder, although this is a bit controversial. Some people say, like, oh, I'm not committing, I don't know, third-party code in my repository. That's something bad, awful. Some people will say, yeah, I'm always committing. I'm on the always committing side, of course, if you're not a library. And the reason why I do that is to ensure that regardless of the state of the outside world, my integration system will be able to build the application. The developers working on the application will be able to just update their sources and then build it. There's no dependency on the external world, means there's more rate of success for your CI system. Show of hands if you had GitHub breaking at mid-deployment process, or just when you had a critical bug in production and you wanted to fix it. How many of you? So there's one at least. So yeah, you don't want to have that happening and you're like, oh my God, what now? Where do I fetch this library from? How do I do it? Do I push it in my CI system? Like, yeah, you don't want that, so probably committing your vendor folder is the best option. I said earlier that we currently don't have a good way to handle dependency management in Go. And to that end, we will definitely have, sooner rather than later, hopefully, a proposal from the community with the support of the Go team. It's currently led by Peter Burgan. You've seen him earlier, maybe. He is trying to unify all the vendoring tools that are out there into working together and have a proper package management system for Go. That, however, means that we shouldn't rush into build a complex dependency tree once we have it. So what I mean by that is if you've ever took a Node.js application, for example, you may have seen that NPM pulls a lot of libraries just to achieve simple things like left pad. Anyone? So yeah, maybe you don't want to start having a dependency for everything that's out there, or I'm not saying building simple library is bad, but I'm saying maybe you should try to understand what that library does and see if it's worth importing it in your dependency tree, or just maybe write your own. Or as Rob Pike said at some point, a little copy is better than a dependency. So there is that option. You shouldn't trust implicitly the tool into, yeah, I'm going to fetch this dependency externally because I know people are using it and it's good. You should also, like I said earlier, do a review of it and go through the code and see, okay, is it doing what I think it does? Do I like the way it does it? Is it the Go way of doing it? That's pretty important. It also happens in various languages out there that if you use a dependency management system or a package manager, you will sometimes see projects which are not updating their dependencies for months, years, sometimes. And you're like, okay, I'm using the version that was released maybe 3 years ago. Why? You might have security problems in that 3 years lifespan, which could be critical to your infrastructure or to your business, depending where your application will work on. So try to make sure your dependencies are up to date and you have all the security patches in place. And yeah, don't trust the dependency source. You might do a git pull or go get from github.com dlsniper demo because it's an awesome demo library. But my account might be hacked as we speak, and the next pull you do might be some nasty worm or something that breaks and changes all your things in there. So always make sure you are building the same thing that you have on your machine and you know it's working. That being said, we want to test the application we've just built because we have a bunch of logic in it and we want to make sure it's working. Go allows you to do a regular testing, but it also has some nice helpers. For example, the black box testing, which allows you to basically test the package as you would from the perspective of another package or not having access to the internals of the package being tested. And you can do that as you see in this example. You have a package demo, which has a add function. And then you would have a demo test file. That's the normal way to have test files in Go. But the package name is a bit different. It's the only package that's allowed to live within your current package that has a different name. And that means that you will now need to import demo, the package itself that's being tested, in order to access the functions in it. And then you'd write a normal test function. The big difference when doing this means that you have access only to the exported functions or anything else that's exported from your package that you're testing, which can help you also in test-driven development, if you do that, because you can now see, okay, I'm writing the tests for my application. I won't change them. And when I know now the API for the package and how my functions or methods on structures should look like, I should just go and implement those. And it's going to be a bit more simpler. At least that's my personal experience with it. You also have tested documentation, which is a nice feature of the Go testing package. Probably little known to many users of Go. And you can basically have either the same format with demo_test for the package name or have it in the demo package. And you write a function which starts with example hello. And yeah, in this case, you could say, OK, I want to show how to call the function that I'm having an example for. And you can say, OK, this is how the call looks like. And this is the output. And the Go doc will go on and show you a proper example output of this example. So your users will now be able to test the example itself and see how that looks like. Plus, your CI will also have a way to test that. Of course, the example has an unused result in compiling, so yeah, it's for demo purposes. And finally, now that we know how to test the application and test the examples of the libraries we are using, we should build it. And I know it's a bit of a wall of text, but basically, if you want to build a statically linked, no CGO, Linux AMD 64 supporting binary, which has a version in it, you would do something like this. And yeah, the slides will be online a bit later on, so you can copy-paste that command. There is this flag, which basically allows you to set a variable inside a package. In this case, I'm setting in package main the variable version with a certain version. And that's going to be useful, especially if you do structured logging, because you can add that version to your log lines. So when you have many microservices deployed across, I don't know, thousands of machines or even tens of machines, if you do rollout deployments, you might not necessarily know of which version of my application actually produced the error. Was it the version that I'm rolling out or the version that I'm phasing out? So yeah, it can happen that you have multiple versions of the same application. So in that case, this trick could be quite useful. We have our application now. We are proud of it. It tests, it builds, everything is cool. The next thing is we want to benchmark it or profile it, because that's what we do. We want to make things run fast, and we are always, yeah, I want it fast. That's why we use Go, no? Many of the questions that I've seen with regards to performance in Go are like, oh my God, it's using a garbage collector. It's going to be slow. I know it. I just know it. Or, yeah, I think this implementation will be slow. Or any other variation on that. So I want to have an experiment with you. I'll give you a bit of time to read this and think which one is going to be faster, the sprint or the sprintf call. Okay, right? Show of hands for sprint. Who thinks it's faster? Okay, a few people. sprintf. Okay, fewer people. Right, so do what Boromir says. Don't assume that's going to be fast or slow. Profile it. Do a benchmark on it. Like, seriously, here's the results. On my machine with Go 1.7 RC6, 8 cores machine, you get these results. Sprint is twice as slower than sprintf. So, yeah. No, right? Like assumptions. You would assume that sprintf has a lot of things to do because, yeah, it's going to do some pattern matching and something else. Turns out for a simple string, it's faster. Well, should you use that going forward? I would say integrate that in your pipeline. Put a benchmark or multiple benchmarks in your pipeline and do something like this. Have your CI understand when you're doing the build, is it faster than before or is it slower? Have some thresholds for your build failing if it's slower. Maybe you don't want to introduce in your hot path a code that's suddenly 3 times as slower as before. And of course, always make a change, profile it or monitor it if you can't profile it, although you should, and repeat until you're okay. And there's one more thing which is not on the slide. Think about your implementation, your algorithm. Is it supposed to be fast or is it supposed to be slow? So your implementation, if it's n squared, might be slow because of that, not because you have a good writing in Go. That won't help you. Yeah, there's a better way to do it. think about if it's actually important for you to have a fast code in that place. Maybe it doesn't matter. Or even better, the -1 allocations code, which means don't run that code. If it's possible, simply don't run the code. Like the code that's not there, it's going to be the fastest. And yeah, everything else, it's just depending on the case. Deployment part. When I was doing this talk with a friend, he said, so yeah, basically you're going to tell them you can deploy Go everywhere. And I was like, yeah, I'm just going to tell you that. Go basically runs everywhere. Currently, it even runs on mainframes. There's no one recommended true way of deploying Go applications. If you already have a way to deploy applications in your languages that you are using, Go should be perfectly adaptable to that environment. Sometimes you might do some hacks which are not that good, but it works. You'll be fine. It runs on Raspberry Pis, so you know, if people can run Kubernetes, which is built with Go, on a Raspberry Pi, I'm sure you'll find a way to run the application in your cluster. Oh, and yeah, of course, I couldn't have a talk about deploying the applications without containers, because they're the new hotness, no? I would say start with Scratch, Alpine or BusyBox, one of them, as base images, and then work your way up if you actually need, let's say, some C libraries or functionality from a certain operating system. Otherwise, keep your containers to a minimum. And yeah, don't ship a container which has the Go sources inside it and has a Go run command at the beginning of the container, because that's not how containers are intended to be done. And finally, as we are running out of time, there's the tracing and monitoring part of running applications. We've seen earlier both Peter and Matthew talk about tracing and distributed tracing. There are a few libraries that do that. The GoKit one is compatible with the open tracing implementation, and so is the XNet trace. There is a server coming up from Dominic Honef, the guy behind Go Static Check, if you know him like that. He actually said, yeah, I hate how Zipkin works. I don't like the interface. I want to build a distributed tracing server in Go. So he's actually working on that problem right now. I know he's willing to get a lot of contributors or testers for it. So if you have a need for tracing in your organization, try that and yeah, help build something that's really cool. And finally, we have monitoring. And I'm going to talk a bit about local monitoring. If you want to see your garbage collector or anything else that you can use from xvar package in Go, there's the divan xvarmon package or application. It's intended to run on your machine to either profile or, well, better said, monitor your applications, the local ones, and you will be able to see things like garbage collector poses and many other things. And if you go production, there are a couple of options written in Go that I know of. There might be more out there, but these are the popular ones. It's Prometheus and Snap. Prometheus is done by the guys at SoundCloud, or started there, and it evolved. And Snap is done by Intel. They are similar in many ways, and the major difference would be Prometheus uses a pull system to pull the data from your hosts, whereas Snap uses a push model to ingest the data from the host. There's a few other differences, but yeah, basically those are the major ones. To wrap this up, I would say take care of your dependencies. Make sure you always have them when you need them in your pipeline, on your machine. make sure that you are building a simple system that doesn't need too many dependencies. You can adapt any Go application to be deployed in current environments. So regardless if you're on GCP or AWS, Azure, whatever, you should be able to deploy a Go application. Maybe you don't need performance as much as you think. And when you do, don't assume. Always profile, do benchmarks. You've seen how simple they are to write. And yeah, try to remove the code if necessary, because that might be actually a good decision. And finally, log what's important for you so that you can actually debug your application. Trace and monitor everything else. And with that, I think we are out of time. Thank you very much. And